Great. Thank you all for being here today. My name is Mike Gurr. I'm the General Manager for Manufacturing Automotive here at Hortonworks. And today I want to talk to you about what we're going to call the rise of the real-time connected enterprise. And it's really about how big data can enable digital transformation within manufacturing companies. So when I look at the agenda, we're going to talk about digital transformation that's occurring within the industry. We're going to talk about how the Hortonworks data platform is enabling digital transformation. And then I'm going to spend some time giving you some customer case studies. Two that are occurring at Ford Motor Company, and then one that's actually happening with the city of Las Vegas, which I think is very interesting because we're seeing the connected vehicle kind of morph into the connected world, right? So the connected vehicle with connected cities. So we'll talk about all of that. So let's just talk a little bit about digital transformation, right? It's interesting. If you look in the United States, in the Fortune 500, right, 88% of companies that were in the Fortune 500 in 1955 are no longer in business. And when you look at why companies have gone out of business since 2000, digital transformation was cited by Accenture as the main reason that these companies failed. In other words, they didn't digitally transform. So, and that goes kind of against, this companies should be digitally transforming, because when you see that, what McKinsey is predicting is that 50% of companies can actually improve their bottom line by 50% over the next 5 years. So it's very advantageous for companies to go through this digital transformation initiatives, yet only 42% of companies actually have formal digital transformation initiatives underway. So the interesting thing that we're going to talk about today is how can big data and big data analytics drive digital transformation for manufacturers. So when we look at how the world is changing due to digital transformation, we're moving into completely different business models, right? We're moving from a world in which manufacturers manufactured products to now they're manufacturing connected products and IoT-enabled services, right? And by the way, the IoT-enabled services that we're talking about are actually have higher profit margins than the products themselves. So you see companies like Boeing shifting their whole movement from a product focus of making airplanes to the services afterwards, right? And we're seeing this in industry after industry. The second trend we're seeing is that business processes themselves are shifting from being scheduled and kind of batch to being real-time. And this is a trend we're going to talk about a lot today. We're going to give you specific examples. So again, real-time processes. From a customer experience perspective, we're going to actually addressing customers as groups or segments to actually treating people as a segment of one. Right, so we're seeing things like personalized advertising. We're seeing things like recommendation engines, all being enabled now due to big data. Finally, we're seeing data move from silos to networks. Right, these are some of the transformations we're seeing. So we're seeing these transformations, and they're happening fast, and they're happening across all of the different manufacturing sectors. So just the evidence for this is actually very interesting. When you see what Forbes is actually talking about, IoT-enabled service revenues are projected to increase 27.1% per year from 2015 to 2018. We see manufacturing IoT, so sensors and connected devices in factories, that's going to grow 27% per year. Digital supply chains that are now acting on real-time information like truck GPS, RFID tagging, right? We're seeing that growing tremendously. And by the way, companies that rely on digital supply chain data can respond 25% faster to supply chain changes based on research by BCG. And finally, from customer experiences, right? Customers are now, and by the way, whether they are business to consumer or business to business types of manufacturing companies, those customers are expecting personalized attention right now. So again, it's no surprise that we're seeing companies move to digital real-time advertising and marketing, to things like personalized recommendations through recommendation engines. We're seeing these types of things happening all the time. So when you look at what it takes to be a digital real-time company, what are the barriers that are preventing companies from doing that? First of all, it's the ability for these companies to take in these new types of data sources, right? So the real-time data, they can't ingest it. That's number one. And whether it be from customer information, whether it be manufacturing information, whether it be from connected products and services, many companies have not started that journey in terms of connecting their products. The other barrier that they're seeing is that they have information within traditional systems, database-based systems, transactional systems, ERP systems, CRM systems, and all of that data is sitting in siloed applications, and it's very difficult to get to all of that information so that you can make decisions. So the end result is that customers and companies are having an incomplete view of enterprise data, of their enterprise, right? So they cannot say, what is the state of my customers? What is the state of my operations, my manufacturing operations? What is the state of my products in the field? This is where a modern data application can help. It can pull together all of these types of information. So when you look at what's required for connected enterprise, first of all, we say we have to bring in all of the information into one place, into a data lake, right? And whether it's new type of information from those connected devices, whether it's new types of information, the new types of web click streams and those types of information, in addition to pulling in all of those other types of data sources from ERP systems, from CRM systems, from supply chain systems, we see our customers pulling all of that information together so they can do things like have a 360-degree view of the customer for the first time, including both social channels and all this customer experience touchpoint information in one place and mixing that with their CRM profiles. We see customers doing the same thing with setting up manufacturing data lakes, right? Bring in my ERP information along with sensor information, and then be able to do things like figure out predictive maintenance for plant equipment. We're seeing a lot of use cases in that area as well. So first of all, collect all the information, put it in one place. What Sanjay Radia talked about earlier, which is very important, is that then creates the foundation to do machine learning. Once we have this data, let's build out those machine learning models that help us, for example, predict when a customer will buy something based on certain offers. Or it'll help us to predict when our machines are going to fail based on certain operating conditions, right? So learning and optimizing is really important. But the third piece, which is really important, is then to take those models and to deploy those to the edge. Right? So as data is streaming in, we're making those decisions. We're doing those optimized customer interactions, those optimized manufacturing operation decisions in real time. Right? So this is what it takes to be what we call a real-time connected enterprise. Now, let's talk a little bit about how you achieve that. What would an architecture look like that could help you achieve that? So when you look at the architecture, we start off by saying, look, we've got different types of real-time data sources. That could be from connected products. It could be from connected manufacturing, right? From my sensors, from my PLCs or programmable logic controllers, from my data historians, right? We can pull in all that type of information from the manufacturing shop floor. We can pull in real-time connected supply chain information, so GPS information. Where are my trucks? Where we could have RFID tagging on the inventory itself, so we know where is the inventory. Right? We can start to understand from the connected supply chain We can collect big data in terms of what are people actually buying in real time, and we can start collecting all of that type of information. And connected consumer information, the same thing, click streams and everything we talked about. We can pull in all that information in addition to your enterprise transaction information, and the key point is to ingest that and pull that into a data lake where we can start to do analytics on that. Once we do that, again, we can store it. We've got great capabilities to actually process that data directly within the data lake, within Hadoop, right? So we can do things like data quality workloads, right? We can normalize the data so we can start doing some analytics on it. And then we can do kind of more simple things. We can actually then just go in and do data discovery on that and do business intelligence on that data. That's the simpler use case. But if we want to become a learning organization and we want to be able to start reacting in real time, what do we have to do? We actually have to be able to pull in that information, look at those large data sets, find patterns in that data, start creating my machine learning algorithms that help me predict when things will fail, that help me predict when customers will buy, help me predict when my supply chain is going to have disruptions. Right? We build out those models, and then what do? We're going to deploy it, so that when we're monitoring it in real time, we're actually applying those models in real time. So we're doing real-time monitoring, and then once we recognize things are out of bounds, we can actually take an action. Okay, and that action might be a recommendation. That action might be to do maintenance. But at the end of the day, we're becoming a real-time organization based on knowledge, and that's kind of the key architecture that we see. This is the key characteristics that we see as being very important to achieve this digital transformation we talked about earlier, and this is the kind of the architecture that we see to achieve that. So, when you look at what does Hortonworks bring to the table in terms of this type of solution, we actually bring. And you guys have heard about this morning. You've heard about Hortonworks data flow, which is very useful in terms of ingesting that information, processing that data as you're ingesting it. We can then store the data in the data lake, right? And that's Hortonworks data platform, HDP. And by the way, right from the data lake, as I said earlier, we can do all that machine learning. We can bring in all the tools that Sanjay talked about earlier in terms of being able to do machine learning directly within Hadoop. And then what can we do? And then once we create those models, we'll push it out, and HDF has the capability, and we've got the capability to deploy those learning models directly into the data stream within HDF. So again, we provide a complete solution to be able to enable kind of more of a real-time connected enterprise. So, what kinds of customers are we working with? I want to give you an example of a customer that we're working with. We've done a lot of work with Ford Motor Company. Ford Motor Company, and by the way, what I'm presenting here is what Ford presented at our Hadoop Summit. This is presentation materials that they've created. But the interesting thing is that, as everybody knows, Ford is transitioning from a car company to a mobility company. So in terms of their digital transformation, they're saying, look, yes, of course we will make cars and vehicles, but the whole business model's changing, right? We are now providing movement, right? We're helping people move from point A to point B, whether they own the car or not, whether we're just providing transportation as a service. This is the business model that they're moving for. And to do that, they said, you know what? Connectivity is obviously the first order of the day. We have to make sure that our vehicles are connected, okay? And so what did they do? We'll show you how we actually helped Ford connect their vehicles and put information into a data lake. And that was kind of first phase, right? They said, put it into data lake, we'll do some simple analytics on it. But the next phase that Ford has talked about with us is they are using that platform to create their streaming analytics platform. And we'll walk through what that means in a second. So this slide was from DataWorks Summit 2 years ago, 2016. Okay, so not the current DataWorks Summit, it was the DataWorks Summit before it. And in that session, Ford presented this slide. And they said, you know what, we needed to, and we set up a data lake that took information from our connected vehicles, from the Ford clouds. And by the way, they set up multiple Ford clouds because each country had to, particularly in Europe, you had to land the data physically within those countries. This necessitated Ford being able to collect data from into multiple different clouds. And the job then became is ingesting all of this information from these clouds into the Ford data center so that you could start to do analytics. And Ford saw this as being critical. They announced an initiative called Big Data Drive, and where they allowed all of the Ford employees, was the first time they started to do this, and they started collecting data from employees to figure out how people were actually using their cars. And then they expanded that to the use of their 2017 Lincoln cars, and they've been growing this out as well. But you know, what did the Big Data Drive actually achieve? They said they saw these types of simpler analytic use cases that they wanted to implement. And the first one that they did was they started to understand and collected the data from the vehicles. By the way, when they started up the cars, when they shut down the cars, they're collecting diagnostic trouble codes. There were certain things from the CAN bus they wanted to understand what features people were using in the car, so which options were they using. And Ford wanted to do this to understand which features in the car were customers actually using or not using, and they used that as a strategy to build out what options and what features in the car were provided to customers in each of their option groups. So when you order a car, it says which options, how should we package those things, and that was based on having this data finally available to them because the vehicles were connected. So this was just one example, a set of examples they said from phase one. We're still in 2016. In 2017, Ford kind of made the shift to streaming analytics. And they said, wow, now that we have done the foundational work, now that we've actually set up our data lake, and we can start to do simple analytics, now let's actually look at that data that we have within that data lake and start to build out models so that we could actually deploy those models, you know, on the edge, so we could start to do streaming analytics. And if you look at this architecture, it's kind of very interesting. You look at at the top, you see this is what they call the real-time layer. Okay, and that's where we were collecting the data. You see it kind of forks back down and gets stored, and that's called what they call the batch layer, or it's the storage layer. That's where you're putting it into Hadoop, right? And you see analyze, that's when you're starting to build out your models. And then what do? You actually deploy that back up into the stream, just like what we talked about earlier. So I think the lesson here from a Ford perspective is to say, look, let's start small. Connect your products. Put the data in a data lake. Start doing simple analytics use cases. That takes time, and you have to get that set up first. That is foundational, and I think we've heard from Mitsubishi Fuso today that this was something that was very important to them. So let's get that started, but then that provides you the foundation to actually to move to much more of this kind of real-time decisioning type of paradigm, right? Which is, I think, where all customers really want to get to. So that's Ford. The other case study that I want to talk about is work that we've done with smart cities, and the customer. And I think this is really interesting because everybody kind of inherently understands that connected vehicles are here and they're here to stay, but connected vehicles are actually morphing into a broader connected world. So, for example, as I said here, we are working now connecting the vehicle into smart city infrastructure. We're working with companies like Progressive. Okay, Progressive is using our technology to ingest connected vehicle data into their platform so they could understand how their customers are using their vehicles, and therefore they could customize the policy quotes that they give to those customers, right? So connected cars, connected cities, connected connected insurance. We see this over and over and over again. The car is becoming a part of a much broader ecosystem. So let's talk about the work that we did with the city of Las Vegas. So this initiative started, and this is a copy of the press release that the city published in January, just last January. They said, we are having a lot of traffic fatalities in the city of Las Vegas. In fact, the city of Las Vegas had the second highest rate of pedestrian fatalities in the country. Okay, and so the city of Las Vegas is saying, wow, we're having a lot of people who are getting hit by cars. How can we use technology, and more importantly, how can we use connected vehicle and connected city infrastructure technologies to help prevent these types of accidents? And they announced this pilot, which they call the Las Vegas Connected Vehicle Pilot. And this was the official press release. And you could see, by the way, that this was a press release between the city of Las Vegas and Geneva. Let me just talk to you about what Geneva is. Geneva is an open source connected car consortium. Okay, so Geneva promotes open standards and open technologies for a connected car, and they've built out this connected car stack. If you notice, it's a consortium of both automakers and suppliers and technology providers like ourselves. And the key point is, if you look at Jaguar Land Rover vehicles, they use the Geneva solution, the Geneva open source solution. So all Jaguar Land Rover cars that are being sold now today around the world use this technology stack. And if you see here, these are the members of Geneva. There's OEMs, automakers at the top, tier 1 suppliers on the next layer down, and then a whole set of technology providers, of which Hortonworks is the big data platform for Geneva. So we worked with the city of Las Vegas in a partnership with Geneva. Okay, that's how we all work together. So why did the city decide that they had to do something with technology? As I said earlier, in 2016, Nevada experienced 213 pedestrian-related deaths. And a lot of these things were caused by people crossing the roads in dangerous places in Las Vegas. People were getting hit, getting out of buses and running across the street to the bus stop. So the question became, how can we use technology to help reduce these fatalities? And we'll talk to you about how we did that. So the city of Las Vegas created this connected vehicle pilot, and they said, first of all, what are we going to do? We're going to take the city fleet vehicles. So these are all city government vehicles, right? 200 of them. And we are going to connect them. We're going to make these connected vehicles. And then we're going to monitor 4 use cases. We're going to be able to monitor if those vehicles are speeding, if they are approaching a high-risk area. By the way, and all of these things are defined by the geofencing information. Are we approaching an active bus stop? And an active bus stop is not just approaching a bus stop, and we have the geofencing information, but also, is there a city bus in that bus stop? So the bus stop has to be active. So are we approaching, is that driver approaching an active bus stop? And if so, what they did is what they said is we'll actually send an alert back to the vehicle if any of those conditions occur. So that's basically how they did it. So how does our architecture work in a situation like this? So this is the city of Las Vegas system architecture. And what you see on the right-hand side is the city vehicles. We actually ingested all that information into this Geneva RVI server. so that provides the connectivity of the vehicle to the server. And then we used Apache NiFi, that's Hortonworks data flow, okay, to actually take all that information, to ingest it, to process it, to transform the data, I'll give you more details in a second, to take this information, we'll process it, we'll combine it with real-time data sources from the city. Remember I was telling you the bus information? So we know all the different bus locations, where are the buses. In addition to, we combined it with static city data. So those are all those geofencing information. So what are the speed limit zones? We can geofence that. Where are the bus stops? We could geofence that. That's static information, right? So we took the vehicle data, we combined it with real-time city, real-time bus data, the static information, where are the speeding zones, we took all that information and did real-time analytics on it, and then we also stored this data long-term in Hadoop. But we used we used the Hortonworks connected data platform to achieve all of these different results. So this is just kind of, I want to walk through you what this looked like in the tool itself. So the first thing we had to do, as I mentioned earlier, was ingest that information. What you're looking at here is Apache NiFi, right? Hortonworks data flow. Okay, and the key thing here is we will walk through the process. The first thing we did is we actually ingested the information using a web service. And one of the key things here that's really important to realize is that you're looking at this flow. This is a drag and drop user interface, right? You don't have to have programmers who are programming here. They'll drag in these different reusable building blocks and then just configure parameters on it. So here we say, okay, let's listen for a web service. We use the listen HTTP processor. Then what do? We actually split the data. We said, okay, let's extract the GPS data. That's the location data. And we extracted the vehicle speed data. Okay, we pulled out those two different pieces of information. Again, you see, this is all done graphically, very easy to do. And then we're going to format it for each use case. And remember that I said there were 3 use cases. Use case 1, 2, and 3. Use case 1 was, am I approaching a speed limit? Am I over the speed limit? Use case 2 was, am I approaching a high-risk area? Use case 3 was, am I approaching an active bus stop? So let's actually now drill down into the use case 3 for the active bus stop. Oh, and by the way, after we reformat it and we store it in Hadoop for long-term storage, why is that? Because later on we're going to see, once people got that warning, did they actually slow down? But we'll talk about that in a second. So let's drill down to use case number 3, active bus stop information. So we'll bring in the information that we just processed from use case number 3, and then we build a query. We're saying we know the vehicle location, right, from the connected car. We say query against the geofencing information. Is the car approaching a bus stop? Is it approaching that bus stop location? So that's question number 1. Number 2, we say, determine if the bus stop is active. This is where we see, is there, remember the city bus information? We combine that in, the live city. Is there a bus in that geolocation as well? If the vehicle is approaching a bus stop where there was a bus, so the bus stop was active, we then sent out an alert to the driver. Okay, and this is so this is an example of how you could very easily create these different connected vehicle flows, which, and by the way, being able to create these very easily is very important, right? Because with connected vehicle flows, the industry is saying, everybody in the industry is saying, we don't really know what all of the potential use cases can be within the industry. So the ability to be able to build these flows very quickly and dynamically without having to be a programmer has a lot of value. So where are we with the pilot? So as I said, we started in January and we finished in October, right? And we'll finish in January. The results will be announced at the Consumer Electronics Show in January. But right now what we've done is we've installed these devices in over 100 city vehicles. We're going to get it up to 150 vehicles. The objective is going to be, for every one of these use cases, when we give the warning, we're going to do analysis to see if the drivers actually slowed down, and that's going to be the measure of how successful this pilot is. And so we're looking forward to getting those results in January. So for anybody who wants to get more information on this, maybe for your local governments, there's a lot of governments who are looking for the results on this. This is the site where the official project site, and they're constantly updating it with the status. They're actually making the data available for other people to analyze it as well, because they see that this is something that could be very important to other cities as well. Okay, so when you look at kind of the Hortonworks solution and kind of the benefits we think it can bring, first of all, we think it will help companies financially. Because first of all, as we said, as you move towards digital transformation, we can see that these types of real-time solutions help increase revenues. As we said, it's kind of interesting. Forbes said that manufacturers expect IoT. If companies do connect their products, they expect their revenues to go up 27%. They also expect increased revenues of 4 to 8% just by providing a better customer experience. And there's all types of operational cost savings that you can get from having connected manufacturing, right? Improving your plant uptime, reducing your equipment maintenance costs, and improving your supply chain by making that supply chain really real time as well. And then there's a whole set of what I'll call IT types of savings that you can get. You can rapidly build out these IoT-enabled flows that we talked about. Again, the user interface driven, end user driven, and you can help manage complexity for this type of environment, because Hortonworks will provide a single platform to create these IoT-enabled flows, to create enterprise data lakes, and to create and deploy these machine learning models that we were talking about earlier. And finally, we think there's reduced risk in terms of all of the security that we're building into the system. Right, so we've got data security and governance built into the system, and the other thing is that we see this as being the open source solution is really important here, because this area, there's so much innovation going on right now. No one company who's building a proprietary system could ever keep up with the pace of innovation. So we think that it's a lower risk solution as well. So again, we see digital transformation happening across manufacturing industries. We've got lots of different examples of it. We feel very privileged to be working with leading edge companies in terms of helping them further their transformations, and we're very excited about the future. So with that, that's basically what I wanted to present. I want to thank you all for listening today.
ありがとうございました。